Let's have another example of Bayes' theorem. DJ Music Store gets its supplies of CDs from New York and San Francisco. New York supplies 65% of its inventory, and San Francisco supplies 35%. CDs from New York are defective 5% of the time, and those from San Francisco are defective 8% of the time. The store wants to know the probability that a randomly selected CD comes from New York given it is defective. Pause the video and try to see if you'll be able to figure that one out. Alright, so let's list down what we know. The probability that the CD is from New York is 65%. While the probability that the CD will come from San Francisco is 35%. So there you go. Let's change that color, because I think it would be better if we write this in green. So there, San Francisco is 35%. So, CDs from New York are defective 8% of the time. So that means the probability that the CD is defective given that it came from New York would be 5%, while the probability that the CD is defective given it's from San Francisco is 8% of the all 8% of the time rather. So let me just change this color also to make it consistent. This is 5% while the other one is 8%. We are now asked what is the probability that a randomly selected CD is from New York given it is defective. So we can use again our illustration to draw this one out. So we'll have this one here. There you go. And of course, we have our line here that divides. If it's from New York, then you have 65%. Then for San Francisco, that is 35%, because that actually consists of 100% of the CDs. Now, the probability that it's defective given it's from New York is 5%. So, 5%, let's just represent it like this. So this area is 5% of 65%. So let's get that. The 5% of 65%, which is actually 3.25%. 3.25%. Well, the other thing here that we know is that it's defective given it's from San Francisco. So let's draw that line again. A little bit higher this time because it's a little bit higher there, but let's move it down a little bit. There you go. So this one here is that 8% of the 35% are defective. So that means we'll have 8% times the 35% would now be equal to 2.8%. 2.8%. A little bit small, but there you go. So that meant our probability of the CD coming from New York, given it's defective, would be, let's write that down here, the probability that the CD came from New York, given it's defective, would be this one here, this percentage, 3.25%, all over the total number of defectives, or the total percentage of defectives, which is 3.25% plus our 2.8%. Oops, maybe I should have written this in blue also, since anyway they're all defective, 2.8%. And that will give me an exact fraction of 65 over 121 or in percentage, so it's easier understood by the others, around 53.72%. That means there's a 53.72% chance that given that the CD is defective, it's from New York. So that's a more than half chance. Again, showing our formula. Let's write it down here. Oops, let's keep that drawing up there. The probability that the CD came from New York given it's defective would be equal to the probability that the CD came from New York multiplied by the probability that the CD is defective given it's from New York all over this same number here times the probability it's defective given it's from New York plus the probability that it's not from New York, which is just San Francisco. The probability that it's from San Francisco multiplied by the probability that it's defective given it's from San Francisco. Now, if you notice, I did not use the complement of New York because we already know that the complement of the CD being in New York is the CD being from San Francisco. And this will give us the following values. This will give us your 65% times 5%. That's what we did up there. All over the same number, 65% times 5% plus the one from San Francisco, 35% multiplied by this probability of 8%, which will still give us the same result. That's another example of Bayes' theorem.